Welcome to Brain Vision.
Okay, so we're trying to find the position vector of a particle that has the given acceleration vector as 2t sine of t and cosine of t. And the initial velocity is given by I, and the initial position is given by J. Okay, so now first of all, if a function f is integrable, then it can be written as f of t0 plus t0 to t f prime of u du. Because you see, if you evaluate this function f, it doesn't really matter if it's a single value function or vector function, then you get f of t0 plus the integral from t0 to t0 f prime of u du. So this term is 0, right? Because we were taking the integral from a point to the same point. So this is what we're going to use to find the velocity and position vector. Okay, so since we have the acceleration vector a of t, we can find the velocity vector by integrating the acceleration vector and sum it with the given initial value of the velocity vector from 0 to t, and then the acceleration vector to u sine of u cosine of 2u du. And this is the integral. I'm denoting this by the integration component wise. So we have the initial velocity as 1, 0, 0 plus, and then take the integral component wise and get 2u squared over 2 minus cosine of u, and then 1 over 2 times sine of 2u from 0 to t, which equals 1, 0, 0 plus, you can eliminate this, and then t squared minus cosine of t 1 over 2 sine of 2t minus 0, negative 1, and 0. So we get 1 plus t squared, 1 minus cosine of t, and then 1 over 2 sine of 2t. Okay. Now we're just gonna take the same step, but replacing a of t with v of t in order to find the position function. So r of t equals r of 0 plus 0 to t, 1 plus u squared, 1 minus cosine of u, and then 1 over 2 sine of 2u du. This is the velocity vector that we found above, and this equals 0, 1, 0 plus u plus u to the third over 3, u minus sine of u, and then negative 1 over 4 times cosine of 2u from 0 to t. Okay. and then this can be evaluated to t plus t to the third over 3 and t minus sine of t, and then negative 1 over 4 cosine of 2t minus 0, 0, negative 1 over 4, which equals t plus t to the third over 3, 1 plus t minus sine of t, and then 1 over 4 minus 1 over 4 times cosine of 2t. So now that we found the position function, we can graph them using a computer. So when we graph this using a computer, we get the following graph. From the graph is from t equals negative 2 to 2.